In this video, I want to do a couple things. I want to work through a story problem, a word problem, and then I want to review with you like terms and putting like terms together. Okay? Now, our learning target for all of this is to use properties to simplify expressions. Okay. We worked through a problem similar to this. I wrote this one and changed the names, but I want to go through it again because I think there was some confusion and I want us to help us to understand this. When you read one of these, you can write it out step by step, and then you simplify it and you can get the formula or the expression that you can use to find what you need to find. All right, so let's read it. It says this: Joe is X years old. Joe's brother Frank is 7 years older than Joe. Their mom is 3 times Frank's age. Their Aunt Peggy is X years older than their mom. And the question is, how old is Aunt Peggy? So that's what we got to figure out. So if I want to know how old Aunt Peggy is, I know that Aunt Peggy is X years older than the mom. So I just have to do the mom plus X. But do I know the mom? Well, I know the mom's age is 3 times Frank's age. Okay, so then it's 3 times Frank. But I have to find Frank's age. Well, I know Frank is 7 years older than Joe. Okay, so it's Joe plus 7. Now I need to find Joe's age. You see how kind of this is a domino? Joe's age is X years old. Okay, so let's tackle this. Start with Joe. Joe equals X years old. Okay, so by having Joe, I can get Frank. If I can get Frank, I can get the mom. If I can get the mom, I can get Aunt Peggy. And it will all work out. So I have Joe. Now I need Frank. Frank is 7 years older than Joe, so it's going to be Joe's age plus 7. Okay? Now, I want the mom's age. The mom is 3 times Frank's age. So this right here, that whole thing represents Frank's age. So I have to times this 3 times. I need X plus 7, X plus 7, X plus 7. 3 times this. So what I'm going to do is I'm going to put Frank's age down here, and I'm just going to put a 3 here. So it's kind of saying 3 times this. So I have the mom's age. I'm getting close to Aunt Peggy. Aunt Peggy says is X years older than the mom. So if I know the mom's age, Aunt Peggy. So I have to put the mom's age down, and then Aunt Peggy is X years older. So I'm going to add X to that. So the mom's age is this whole thing, and now I'm just going to add X, and that gets me Peggy's age. So now I have Aunt Peggy is 3 times X plus 7 plus X. I'm going to simplify this because I know based on the distributive property, I can get this into simpler. Once I have distributive property, then I can find my terms. Once I find my terms, I put the like ones together, and I have it in its simplest form. Okay? It's never going to be a number because I'm missing X. I'm missing this variable. But it can be simpler than this. Okay? So let's see. I go here to here, so that's 3X. Go here to here, plus 3 times 7 is 21, and then I add my X. Okay? It's all addition, so now I'm going to figure out what are my terms. Because if I want to get to like terms, I have to know what my terms are. So, that's a term, that's a term, that's a term. I have 3 terms. 3x, 21, and x. This one is a constant. It's always going to be the same. These two have coefficients. Okay? Coefficient on this is 3, coefficient on this one is 1. Um, but this is an x and this is an x. They both have a variable, and the variable is the same. And when that happens, they're like terms. I can put them together. 3x plus x gives me 4x plus 21. So there is Aunt Peggy's age. And this is similar. This is simpler than this. I would rather just, if I know x, I put x here, times it by 4, plus 21. Here, I'd have to put x here, then I'd have to distribute this, then add that. That's why this is called simplified. Or simple. This is in the simple form. Okay? Jeez. So, that's what you want to do. Okay? That's how you attack this problem. You take it step by step. You say, what do I need to know? Okay, if I need to know Aunt Peggy's age, I have to find out what their mom's age is. I need to find out Frank's. And you just take it step by step. Okay? And then once you get it down to here, then you can simplify it, and you're good to go. Okay? So hopefully you understand this type of a problem. We'll talk more about it in class. The other thing I want to do, let me get rid of this quick. I can have some clean board. As I talk about how I like to get things to adding and not subtracting. So, say I have this, 7s plus 6 minus 1 plus 7s. Okay? This is an expression. And I want to get this expression in simplest terms, which means I need to know my terms. I need to know all the terms that are in this problem. And then I can figure out which ones are like, and if they're like, I can put them together. So I always like to get things to addition. When I see a subtraction here, I know all I have to do is go like this and there. So I have addition, addition, addition. And now I'm going to circle my terms. There's a term, there's a term, there's a term, there's a term. So in this one I have 4 terms. It looks like 2 are alike and 2 are like. So I see this has no variable, that has no variable. So those two are like terms. So I'm going to go 6, and I'm going to put it together with that negative 1. So this term with this term, I'm putting them together. Okay? Now, just like what I did with, I took it when it was minus 1, I changed that and made that negative 1. I can also take it back. It's that whole thing about keep, change, change. Keep, change, change. When I have a problem like this, I can keep the 6. I can change that to a negative, change that to a positive. Okay? These two things are the same because of keep, change, change. You might like 6 minus 1. You might say that's easier than 6 plus negative 1. 6 plus negative 1 is going to get me 5. 6 minus 1 is going to get me 5. It's the same problem, but you can always do keep, change, change back. I did the original problem. I did keep, change, change to make everything into addition. But you can also use keep, change, change to take it back to subtraction if you want. But if you change the sign, you have to change the next one, whatever it is. If it's from positive to negative or negative to positive. Okay, so let's keep going with this one. I combine these two like terms and I get 5. This like term and this like term, 7s plus 7s equals 14s. Okay? So now I have this 14s and this 5. I'm going to put them together because I had plus, plus, plus. It's always adding, so I'm adding these together. 14s plus 5. And that's in its simplest form. Okay, I'm going to give you 3 problems. 2 are math problems, and another one is something else. Here's what I want you to do for your homework. On a piece of paper, I want you to simplify these 2 problems. Number 1, I want you to simplify 7s minus 4s plus 9 plus 4s. So go ahead and try that one out. We'll go over it in school. The other one I want you to do is 1 minus 10s plus 4s plus 9 minus 10s. Okay? I want you to try and simplify those. Find out what terms you have, and you can make it all addition. Find out what terms you have, which ones are like, put them together, and then get it to simplest form. Now, number 3, I want you to answer a question. If you could have any candy in the world, what would it be? Okay? What candy would you want? If you go to the candy store right now, you can buy anything you want, it would be this. Okay? So I'm giving you 2 math problems and 1 just an interesting question that when you put that on your paper, I'll be learning a little something about you. Okay?